In this lesson, we're going to take a quick look at some issues that you face when you begin modeling your data in JSON, and then a bit about how that JSON is going to map into C# objects through the API controller. So first, well, what does data modeling mean in general? Well, it's how you describe data that's relevant to the target domain, to whatever it is that you're trying to create. So it often is spoken of in terms of entities in the domain, objects and their attributes, like owner has particular attributes and pets have particular attributes. And then there's relationships among those entities, which belongs to which and how, and cardinality. Does one owner have multiple pets? Does a pet have multiple owners? Are they one-to-one, one-to-many, etc.? All of these are issues that you face, and then you end up describing in your data repository in some fashion. Here, we're talking about doing so in JSON. So, are traditional relational models the best choice? Well, it depends. That's always the answer, isn't it? So on one end, you've got the old style enforced normalization of a relational database. On the other end, you've got Couchbase with relaxed normalization. So how do you compare these a bit? Well, first, in the old relational approach, your schema is enforced by the database. It has some advantages to it. It keeps size small and things of that sort. Whereas in the relaxed approach, the schema is inferred from the overall structure so that you can evolve your data shape over time without getting into wars with the DBAs over create table statements. So with the enforced approach, you have the same fields in all records per table, guaranteed by the architecture, whereas in a relaxed approach, the fields may vary by document because they're evolving over time, potentially. Also, in the enforced approach, at least if you fully normalize, you have no duplicate data. On the other hand, in the relaxed approach, your data may be duplicated. It may be denormalized, as it said. Sometimes that's useful in certain cases for speed and other reasons. So in the enforced normalization approach, you have a monolithic architecture by design in the relational world because you're always joining data in memory. Well, if you have to deal with joins in memory, that means you need some very big hardware, and it better keep growing over time. By contrast, in the relaxed approach that Couchbase takes, the architecture, it's scalable, it's clustered. You want more nodes? Add them. You want to drop some? Drop them. That's just how it works in modern software. So, last, the relational approach, it's optimized for data entry, whereas the relaxed approach, it's optimized for data use. Again, you can evolve your document structure over time easily. Just change the shape and keep moving. So what are some of the choices that you make in JSON document design? Well, we go into this a lot more in another course I'm going to talk about in a moment, but you have structural choices like, is there a semantic meaning to the root attribute? Are you going to nest data within nested objects or arrays or combinations of all of them? How deeply will you nest, and how is that going to impact your code? What will be the complexity of values within arrays? How are you going to name your attributes, and how will that map over to objects? We'll look at that a bit in a moment. Also, will some attributes be valued or missing or empty or null, all of which have different meaning, of course, and you'll find that nickel can account for any of it. But again, that's in a different course. The point here is that Couchbase Server doesn't enforce your document structure for you. The document schema is inferable by your actual patterns of use. So to help with that, Couchbase Server does have tooling to infer and report on your document schema, or what we refer to as the flavor of documents. What percentage of documents within a given bucket generally follow the same pattern. So if you want to learn more about JSON data modeling, well, it's right here at training.couchbase.com/online. Take our Introduction to Data Modeling in JSON course, CB105 if you like course numbers, and it'll go into much more detail about everything we talked about on the prior slide with a number of examples so that you can compare and contrast the choices that you might make. Now, if you're going to implement this in .NET, well, let's take a look at one approach to serializing and binding JSON to objects in the world of .NET. It's based around the API controller class. This is Microsoft software. This is not Couchbase software. It's part of the .NET Web API 2. It provides the serialization and model binding behaviors that we're relying on in this particular application. So your JSON is going to be serialized and deserialized and then bound with entities that you define based on the controller that you put together. The customer controller in our case derives from API controller, which is where this functionality comes from, and it's going to take data and bind it with a corresponding customer class that you'll define. We're going to base it on a base class, as you'll see, which will be generically typed. So you'll have, perhaps in JSON, a first name, a camel-cased first name attribute, and it would be mapped over to a corresponding first name property of your customer object. Of course, there may be discrepancies. You might have a certain spelling in your JSON, like last dash name, that needs to have its data placed within a camel-cased last name property. So there are attributes you can use within the class to describe these relationships to ensure the mapping goes correctly. You could well be using objects to describe data within your JSON, like we see billing address here. In that case, you would have two classes defined for customer. You would have customer and an address class, where the address class describes the structure of this nested object, and the relationship between customer and the address would be managed by the API controller. Also, known patterns of discrepancy like camel case can be automatically resolved by API controller by assigning the correct JSON formatter. Now there's more info available from Microsoft about all this. I'll point you in the right direction here in just a moment. Now, in the lab, what you're going to do is define the entities that will be used to model the customer and address JSON data that we're working with here. Let's go in and take a quick look. First off, I just want to point out that at this URL, let me give you a good look here. At this URL, you'll find a very helpful article on JSON and XML serialization in the ASP.NET Web API. And it goes into much more detail about what we talked about briefly on the slides, about the attributes that you can use to define the relationship between your underlying JSON and the model classes that you define. This is where you'll find more information, for example, on implementing this camel case property name contract resolver that attempts to automatically account for slight camel casing discrepancies between your JSON and your class. And there's a lot more here as well. Now, the data that we're going to be working with is shaped like this. I want to point out a few things about it. First off, take a look at the document key and notice that the document key is using a type prefix followed by double colons followed by an ID value. You'll even see, and we'll deal with this later in the course, an incremented value at the end. We have a series of very straightforward name-value pair properties here. We have a nested object, and then we also have a set of attributes that look like something you would probably want to have attached to every object: created, updated, type, and ID. Now notice we do have the type information embedded here as well. That's a choice that we make in our code. And when and how you would do that and why is discussed more in the data modeling course. Here we're giving you some ideas around implementation. There's a separate ID value here that's actually comprised of a username and an increment value. We'll talk about that more as we go along. Just notice that the document key is comprised of those two values together. Now, you will end up making your own design choices. We're just trying to show you the different ways that you can go about your implementation in this particular course. Again, our Nickel course and our JSON data modeling course will talk more about the benefits of some of these approaches. In the code, well, we'll have an entity-based class that provides the created, updated, and ID values and such, which we'll assign over in the repository later. It does take a generic, which is how we get the type properties you'll see. Over in our customer class, we'll have correspondingly named properties to our JSON. Of course, once you read that article, you'll see that you could map things differently there. And then we'll have a billing address, which is typed to this address class, which we'll also have you create. Again, we hope you go through the process of building the lab yourself so that you get the hands-on through the fingertips experience with all of this. Or if you prefer, you can just move on and keep watching videos. Regardless, when you get back, we're going to take a look at the controller and the repository, talk a little bit more about this mapping relationship and how you'll expose this API publicly and start getting data out of your database. So come on back.